So we start with question 1. In question 1, you are given a cantilever like this with a span of 3 meters, and on the left half you have been given a an impulse load of 10 kilonewton per meter, and on the right half there's no impulse load. So the first part asks you to find out the bending moment due to this impulse load at the fixed support. So part A, let's say this is point A. The bending moment at A is simply equal to 10 kilonewton per meter times the length of the loading, so that's 1.5, times the total load is acting at the center of the loading, which is at a distance of 0.75 meters from A, so that's times 1.5 divided by 2, and that will be the bending moment at point A due to the impulse law. So the bending moment at A due to impulse law is 11.25 kilonewton meter, and this is the Hawking moment. And then in part B, you're asked to find out the bending moment due to the self-weight only, and the self-weight is given as 2.25 kilonewton per meter. Of course, the distributed load due to self-weight is acting on the whole beam. So to find out the bending moment at A, that's simply 2.25 times the total length of the loading, which is 3 meters, and then that total load is acting at the center of the beam. So the center of the beam is at a distance of 1.5 meters from A. So that will give you the bending moment at A. The moment due to self-weight is 10.15 kilonewton meter Hawking. Or in part C, the total moment at A due to the impulse load and also the self-weight, you can just add up these two values, which will give you 21.4 kilonewton meter Hawking. Make sure when you write down your bending moment, make sure you write down the unit as well, and state clearly whether the bending moment is sacking or hawking. And in this particular case, this is a cantilever, which will bend something like this. So the bending moment of this cantilever is obviously hawking. So based on that, you can calculate the number of rebars at the top of the cross-section to resist that bending moment. So assuming the internal lever arm is 0.75 times H, and given that the cross-section is 300 by 300, so H is just 300, so 0.75 times 300 will give you 225 millimeter as the internal lever arm. And then to find out the tension or the bending moment, that 21.4 kilonewton meter, you change the unit to Newton millimeter, so that 10 to the power 6. That equals to the tension in the reinforcement, and that in turn equal to the tensile strength of the reinforcements times the number of reinforcement times, let's say you are using T12 12 millimeters diameter bars, So the area of each bar is just pi 12 square over 4. Okay, so that whole thing will give you the tension, the total tension in the steel reinforcement, and that multiply by the internal lever arm will give you the total moment, the bending moment on the left. So based on this equation, you can find out the number of reinforcement for this beam to resist the total bending moment due to the impulse load and the dead load. So N finally it's equal to, so from the equation below, the number of bars required at the top will be 1.83. So that you round up to two numbers of T12, and that T12 is placed at the top of your beam at section AA, because A is under a Hawking moment and the tension is at the top of the cross section.